Hello, everybody. Welcome to the asynchronous lesson for those of you who are not taking the test right now. So, again, Friday this would be the blue group, and Monday that would be the gold group. The next unit that we're going to be doing is on similar figures, and so this lesson is just an introduction to that topic. You probably heard the term similar figures in the past. And so I put up here the traits of similar figures. Okay, similar figures are figures that have the same shape. So for example, see here we have triangle ABC is similar to triangle DEF. And this symbol here, which is a tilde in Spanish, but that's the symbol that means is similar to. Alright, so triangle ABC is similar to triangle DEF. And like when we're talking about triangle congruence, we line up the corresponding parts. Alright, so angle A and angle D correspond, angle B and angle E correspond, and angle C and angle F correspond. And that comes into play here with number 2, where we say the corresponding angles are congruent. Alright, so we know that angles A and D are congruent because A and D correspond here. We also know that angles B and E are congruent because they correspond. Lastly, we know that angles C and F are congruent. Okay, then the other piece of similar figures is that corresponding side lengths are in proportion. Alright, so you could see that from AB to DE, those are corresponding sides, you can see that we're multiplying the lengths by 1/3, which means that the scale factor, as we're going from ABC to DEF, alright, the scale factor is 1/3. Alright, we're multiplying the side lengths in triangle ABC by 1/3 to get the side lengths of triangle DEF. Therefore, if BC is 18 units long, what's the length of its corresponding side EF in triangle DEF? Okay, that's going to be 6. Because 18 times 1/3 is 6. But if we're going from triangle DEF to triangle ABC, now this way the scale factor is 3. Alright, the scale factor is 3 because we're going from the smaller to the larger. And you can see then DF is 3, so we're going to multiply 3 by 3 to realize that AC is of length 9 units. Okay, I'm going to show you one more example when it comes to similar figures. I'll leave this example up for now. This time we'll look at quadrilaterals. I know that we haven't formally covered quadrilaterals yet this year, but we can cover them at least a little bit here. And a quadrilateral is a 4-sided polygon. All right, there are many types of quadrilaterals, and we'll discuss them in much more detail in a couple of units. The parallelograms, rhombi, squares, rectangles, etc. But right now, here we have one quadrilateral and another quadrilateral. And we know that these two are similar, which means again that our corresponding angles are congruent. Okay, corresponding angles are congruent. And now let's talk about some side lengths here. We're going to say that GH is 5, HI is 6. Okay, we're going to say that MN is 20 and KN is 22. All right, so based upon that, let's find the missing side lengths. And you can see, I meant to give you one more here, that LM is 12. That's the other one we need. Not drawn to scale. I know the 12 might look shorter than the 6. Okay, not drawn to scale. So to figure out the scale factor, we're going to look at the corresponding sides where we know both lengths. And we know that HI and LM are corresponding because the second and third letters listed here, second and third listed here. So what is the scale factor from GHIJ to KLMN? The scale factor is 2, which means that when we go in the other direction, the scale factor is 1/2. Thus, if GH is 5, we can double it to get that KL is 10. And if KN is 22, we cut that in half to get GJ is 11. And if MN is 20, we're going to cut that in half to realize that IJ is 10. Okay, so that's the intro on similar figures. Your homework, which will be due for everybody next class, so that'll be due on Tuesday, is the worksheet that I've put on Schoology called Similar Figures, which is due Tuesday. All right, so thank you all for watching, and I hope that you have a good day. Thank you.